Whoa, 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 whoa. Hold the Pythagorean theorem for a second. Autumn, did the clock just strike?
Strike what, Gabe? Did we lose track again? Something is a little bit mind-bending. It seems like fractal exploration.
Not exactly. My statistically significant co-host, we've officially cracked the code on 101 episodes of Breaking Math.
101 episodes? That's like a Googleplex of equations that we've tackled together.
Maybe not quite that many, but it's definitely been a wild ride. For the past 6-7 years, since 2017, we've been on a mission to prove that math is more than just a bunch of dusty textbooks.
Absolutely. It's a secret sauce to the universe. The language of intervention, and yes, the key to baking a pie that won't leave your guests feeling like they need to call geometry for help.
Enough reminiscing for now, though. Today's episode is all about celebrating this monumental achievement with you, our fantastic listeners. We've got a treasure trove of goodies in store, from listener shout-outs to brain teasers that'll have your neurons firing faster than a supercomputer, and a sneak peek at the incredible math adventures we have planned for the future.
So grab your slide rulers and sharpen your pencils, and get ready to break the sound barriers of awesome, because this is an episode you absolutely cannot miss.
I guess it's time for a little bit of a reintroduction of sorts for who we are and what we can do on this 101st episode, which we call The Math Lounge, the episode where we take you behind the scenes of what we've been cooking up. I'm Gabriel Hesch, one of the founders of the Breaking Math podcast.
And I'm Autumn Finef. I'm more of the project manager side of things on the podcast.
Yeah, and I hesitate to say that you've taken up the reins in such an amazing way. So full disclosure, I have a whole lot of kids at home and I have a full-time job, and Autumn is basically taken the reins in many ways, which has been amazing. I mean, everything from writing scripts to finding guests, you've basically, and to editing full episodes, to interviewing episodes. So Autumn has done more than simply only the project manager. You've basically stood in my shoes when I'm not available. So that's awesome.
I mean, I have fun doing it.
Good. Well, I'm glad. We're very fortunate to have you here. Now, Breaking Math has been running since 2017 with a lot of collaboration from some big names on the show, such as the famous physicist Sabine Hosenfelder, who was a phenomenal YouTube channel, as well as Math with Bad Drawings blog and book author Ben Orlin.
Now, we also have had Marcus de Satoy, the Simone Professor for the Public Understanding of Science at Oxford University, and another one of your favorite science illustrators, Zach Weinersmith, from the Webtoon Saturday Morning Breakfast serial. Here's the thing. We've been crunching away at a lot more than just cereal.
Breaking Math Podcast is expanding to Breaking Math Media. It's time to have more than just a podcast for you. We've been working tirelessly with some contributors and collaborators around the globe to help expand your mathematical knowledge. You've helped us grow to the #1 all-time mathematics podcast in the United States.
So we've been tirelessly building a website behind the scenes, a blog, uploading all of our old episodes, creating new partnerships, working on here's a little teaser for y'all, a couple of books, and putting out content on all of our social media channels.
Not only those things, but we also want to work with you. Yes, you, our listeners. We want to open up opportunities to collaborate with us on our show and on our blog. If you would like to have an episode where you would like to share anything in the field of STEM or of art, history, philosophy, etc., and tie it back to mathematics, tech, and engineering concepts, we are open to collaborations.
And if you would like to work with us on a larger scale, whether it's a sponsorship, partnership, or a contributor, we want you to know that the link is in our show notes. We also have everything on breakingmath.io. Now, before we get into who we are, our big questions, and what this really looks like for us at Breaking Math, let's take a minute to hear.
At Zaxby's, we don't just make chicken fingers. We make the most premium tenderloin, 12-hour marinated, hand-breaded, fried to golden perfection. Deserves not 1, not 2, not even 3, but your choice of 12 dipping sauces chicken fingers. Chicken fingers that you can dip, dunk, or drizzle in ranch, and Zax sauce, and spicy Zax sauce, and honey mustard, and tongue torch, and barbecue, and I'm out of time. Woo, saucy! Zaxby's. When it comes to Zaxby's fingers, there's a few non-negotiables. It's gotta be only premium tenderloin, marinated for 12 hours and fried to crispy perfection. What is negotiable? The flavors you create mixing our 12 signature sauces. Woo, saucy! Zaxby's.
Hear from our sponsors.
So as you had heard before our commercial break, Breaking Math, the Breaking Math podcast is now Breaking Math Media, and I'm very, very excited. The goal since the beginning has been to tell stories of the significance of mathematics and the history of mathematics using creativity, using art. And sometimes that's kind of a challenge to do because I kind of feel like the analytical side of my brain and the creative side are different, but also kind of complementary. Do you ever feel that way about creativity?
I really do a lot of the times. You can kind of take one piece and connect it to the other. And, I'll just leave it as you need the creativity to be a mathematician, to be an engineer, to work in STEM. And that side of your brain, even though you may think it's a disconnect, it really isn't at the same time.
Yeah, I hear you. Now, I want to especially send this as a call to action out to our listeners, where if you are thinking of, or if you feel that you have a creative way of teaching about mathematics, you are the one that we want to hear from, whether that's, in some funny comics, kind of like the XKCD comics that are phenomenal. We mentioned earlier, Zach Wienersmith's Saturday morning breakfast cereal cartoon, or any other cartoon that kind of, tells stories and illustrates concepts in mathematics or in science. You're the ones that we want to hear from, and we want to collaborate. We want to collaborate. This kind of stuff excites us. In fact, I do my own cartoons. Y'all don't know this, but I've been tempted to debut some of my cartoons. I'm just too nervous right now, but I've been working a lot on drawing cartoons of our guests. So I think I should finally debut them and see what you guys think. Now, I want to mention real quick here with Sophia and I, the late Sophia, who we all know passed away this past year, and we miss her dearly. She was very creative. In the early days of the Breaking Math podcast, we would do things like go around our campus at the University of New Mexico and do interviews on my iPhone 6 at the time. We didn't use any fancy mics. We just recorded things on our iPhone 6. To this day, if you go to the old Facebook Breaking Math page, there's Breaking Math Community, and then there's the Breaking Math podcast page. They are separate. I'm referring to the latter. Incidentally, I no longer have the login, so it just exists there, but it's a great repository of our old stuff. There is a video. There are many videos, actually, that Sophia created, including one of them that animates an interview I did with a philosophy student talking about math. I don't know if y'all are aware of the story of Socrates and the story of Meno's slave. I don't want to spoil it for you all, but essentially there's an apocryphal story that involves Socrates teaching his friend Meno's slave how to do mathematics. And the point of the story, in part, is to show that slaves are very capable of doing and understanding math, not just humans, because even back then they had the wrong idea about many classes of people, including those who were slaves. And Sophia animated it. It's amazing. It's available right now on the Facebook page. I say all this because, again, we like to incorporate creativity, whether it's cartoons or videos or comics or funny memes, into conversations about math. We think it's delightful and we think it's awesome. I have a couple other examples here as well. And again, this isn't just going to be a trip down memory lane, but for those who haven't listened to all of our episodes, Sophia and I deliberately would do things like make fun of movies in an effort to teach about math. I don't know, Autumn, have I ever shown you the beginning of our episode where we made fun of the Saw franchise during our episodes on game theory?
No, I don't think I've ever seen that.
Hello, listeners. You don't know me, but I know you. I want to play a game. In your ears are two earbuds. Connected to the earbuds are a podcast playing an episode about game theory. Hosting that podcast are two knuckleheads. And you're locked into this episode. The key is at the end of this episode. What is game theory? Why did we parody the Saw franchise? And what twisted lessons will you learn? Let the games begin.
Episode 37, the one where they parody Saw.
So it literally at the time we're just thinking, how do we explain game theory? And at the time, this was years ago. I don't know how popular the Saw franchise is right now, so I don't know how relevant it is. I'm sure it'll be popular again because nostalgia always cycles into being in fashion again. But anyways,
Always.
I had no idea that you could do this, but at the time, Sophia just went to Google and said, "How do I modulate my voice using?" I think it's one of the programs, either Audacity or Adobe Audition, and how do I modulate it to sound like Jigsaw from the movie Saw? That's literally it. And he just did some very simple things to modulate his voice.
That's really neat.
Yeah. And then not only that, but we have a musician, again, another creative, a musician with the show, Elliott Smith, who's been a part of our show. And Elliott Smith did our typical intro music, and Elliott redid our intro music to sound like the intro to Saw. It was amazing. So, I find it delightful to use all these analogies, and I don't know what we would do this day and age, like what movies are popular now and what could we use to talk about, we like to make fun of pop culture, so it's pretty fun, and we've done that as well in other episodes too. We did a 3-part series on black holes, and that 3-part series just got really technical. And Sophie and I were so exhausted after all of the research that we had to have a fun, relaxing episode to unwind. So we did a kind of a science fiction Monty Python comedy called Black Hole Heist, and basically we took all of our knowledge of black holes and all the hard problems of science, like explaining consciousness and explaining where quantum mechanics meets relativity. We put all of that into a blender and mixed it up. And basically, it's a short 17-minute sci-fi about an evil doctor that builds a black hole in a lab that gains consciousness, and then it becomes kind of a Frankenstein's monster story. But every other line is a pun. The whole thing is puns. I think the evil general is named General Specific, and there's also Major Chromatic. Y'all will have to take a listen to it. It's pretty fun. But Sophie and I love to be creative, lighthearted, fun, and bring that into serious conversations about breaking math, or about mathematics and science. And I think that's a good way to do it. It's relatable, it's approachable, it's fun. Not everything is super serious where you have to have a graduate level understanding of mathematics to enjoy these conversations.
Absolutely. And what I really have appreciated about Breaking Math is how much you make the show accessible to people. And it's just making topics that sometimes people won't understand, and our larger, broader audience really wants to be able to understand the world around them. So a little bit about me that the viewers don't know and don't see is that before I like to say that I'm just a mathematician and an engineer, I call myself an artist. So the way that I have always thought about this is, if you're an artist, you think a little differently and abstractly, and you really understand the beauty of mathematics and apply it to everything from designing clothes and being able to, I'll just throw out, maybe even packing a solar array for a space shuttle, putting it onto the rocket ship and launching it into space. How do you do that? That's all art. That's all mathematics. And even those same concepts can be brought into simple things like the configurations of bendy straws. That is all math. That is all polymers. That is all physics. And really being able to study that and the interpretations of that has been a lifelong journey for me in discovery of taking these concepts that are really difficult and boiling them down. A lot of my work over the years has incorporated these topics. In addition to that, I have done chain NFT space where I've sold out 11,000 pieces of art in under 2.5 hours. And I've taken that work and helped create communities with some of the top writers in tech, where there was over, I'd say about maybe 1,000 women that were executives and just smart, educated women who love to be able to do the work that they did.
Nice. That's really
Similar.
incredible. I hope you don't mind me piping in here, but that's one of the things that I really enjoy. I know, and I forgive me, I've said this in a previous episode before, but when I was looking for somebody to help me out on the Breaking Math podcast, and you and I were small talking, it doesn't always come up in my conversations with engineers about what kind of art do you do, but your art is all over the place. It's all over, Twitter, X, whatever you want to call it. Your work in communication with magazines. How many people do you know that have not only taught engineering at a college level, taught mathematics at a college level, been involved in high-end literature? Sorry, I said high-end. How do you say like polymer physics, literature reviews in like biomedical engineering, and are also and also have experience working with a magazine and posting their artwork on Twitter. Like that's really, really cool. So that's experience with communication, with expression, as well as with the analytical thinking required to engage with science at a high level. So yay, that's awesome.
Thanks, Gabe. But the thing is, like, I never expected to fall into this field, right? So sometimes you take a job because you think it's cool, you think it's interesting, and stuff happens along the way, and that is how I have navigated my educational experience, my educational journey, my academic work. And a lot of it has actually fallen under maybe 2 or 3 categories. And people don't think about this stuff. The same topics in origami, blockchain, polymer cross-linkages, industrial engineering systems and networks, and even fundamentals of evaluation when you're going into a company and evaluating them. That is the same math, the same optimization, and I was always wondering, what's the theme? How does this carry through? And for me, it was staying curious, keeping it to supply chains, and finding really cool applications that I was never bored with. And, sometimes being someone who just likes interesting problems, you have to find core themes to get funding to write for your own funding and research. And that like narrates its own story over time and spins its own web. And I know that here at Breaking Math, we have a lot of complex questions that have guided you on the podcast over time.
Yes, absolutely. Yeah. In fact, that's a really good segue into this. Now, I know I didn't talk a whole lot about myself and my background. I'll probably just go over that very, very briefly. But essentially, this podcast was born out of experiences in grad school with Sophia. Sophia was my math tutor at the time, and there were just the more we explored math, both in learning and teaching, I found personally that when you learn a topic and then you go and teach it, you understand it in a whole different way, and you may have light bulbs and applications that go off, boom, 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 in different ways. And I thought, this is so cool. And I almost became like a mathematics evangelist, so to speak. But the audience wasn't always there. Like, my wife didn't necessarily always want to hear about why Fourier transforms are awesome, you know what I mean, or the beauty of Euler's formula. And she tried her best. And I understood that. But I thought, man, if only I could find an audience that really wanted to hear it. So then I just thought, well, let's record it and let's slap it on the internet. Now, also, I want to mention that there are some really big questions that sort of inform the Breaking Math podcast. We talk about the history of mathematics in general, but it's also guided. I think that so much of math is interlaced like strands of DNA with the field of physics, that we talk about the history of physics a lot. There's actually a book that I want to bring up real quick. It is one of the books on the history of physics in my experience, but one of my favorites that I've ever read is called The Quantum Story, A History in 40 Moments by Jim Baggett. But the reason why I bring up this book is it dissects everything. I say everything. It dissects the big questions in quantum mechanics, starting with Max Planck and where he came up with his idea of the Planck constant and why he came up with it, what went through his head, and like how does scientific progress work. Essentially, with Max Planck, he was completely stuck trying to make sense of the observations of light radiation, and you have these models that sort of worked, but only worked in certain cases. And finally, he couldn't figure it out. So he borrowed an idea from a physicist named Boltzmann. And Boltzmann was somebody back in the 1800s who believed that gases were made of individual molecules. I don't think I've lost anyone here yet, right? The whole idea that gases are not this like ephemeral spirit and are made of a bunch of small things, that was a really controversial idea, but Boltzmann insisted that the behavior of thermodynamics and heat can be better explained by statistical distributions of small particles of things. Now we take it for granted that air and gases are mostly described, or very effectively described as
precisely.
Well, yeah, clouds of atoms. So now it's common sense, but for a long time it wasn't, and not everybody agreed with him. Anyways, Planck did the same thing with energy. He thought, what if we assume that it's not continuous, but it's discrete at these very, very small increments? And then very quickly, he came up with an equation that described perfectly the behavior of light radiation at small waves and large waves. The book itself starts with Planck, then it goes into Einstein and his 4 monumental papers on special relativity and on the photoelectric effect, on Brownian motion, and on one duration, where the book goes into Einstein's 4 papers on the photoelectric effect, on Brownian motion, on special relativity, and on the mass energy equivalence in his famous equation E = mc squared. It talks about what inspired Einstein, and essentially he read up on Planck and then applied Planck's model to known and unknown physics, and he had 4 amazing earth-shattering papers, and the paper on the photoelectric effect won him a Nobel Prize. But truth be told, all 4 of them were slam dunks, and those pretty much solidified his status as a scientist. But then the book goes on past that, and it talks about Niels Bohr and the Bohr model of the atom, which is so interesting. It's interesting to me because it's so ad hoc. Like with Bohr's original model of the atom, he threw things together and he described behaviors that were just so. Like he wasn't interested in why it behaved that way. He was just interested in his model explaining the math. And he's like, yeah, at this level, electrons just jump. There's no reason why. They just jump, to a different energy level. And I guess as I'm reading the biographies of these thinkers, some people were obsessed with explaining the why, and Niels Bohr wasn't interested in that so much, which just boggles my mind, and then it goes, there's more to say on that. Did you all know that on Niels Bohr's honeymoon, he suddenly stopped everything and had his wife take out notebook paper and write down a bunch of ideas because he had a strike of inspiration on his honeymoon? Can you imagine what that would be like?
Calls for divorce.
I know, right? On his honeymoon, he starts nerding out about physics and has his wife write down all these things. But anyways, they were happily, as far as I know, there's evidence that they were happily married. So that wasn't a deal breaker at the time, which is good. But anyways, essentially the entire book takes apart chunk by chunk the standard model of physics as we know right now, which was pretty well solidified to what we presently know of the standard model, through things like particle accelerators, through the mathematics of Richard Feynman, including things like quantum electrodynamics and quantum chromodynamics, which explains the behavior of force carriers, at the subatomic level. Anyways, a lot of that is done through, as I said earlier, particle accelerators. But it answers the question of why or how do we know what we know? To what level of precision do we know these things? How sure are we? Where are the uncertainties? And this is just physics and cosmology. And this leads into the Big Bang. And, there's even folks mentioned in this book who I don't remember the name right now, but who are responsible for the whole idea that electromagnetism and the weak nuclear force are one and the same at certain, in certain conditions, and that leads into the Big Bang where things spread out and were super hot and dense, and then they cooled down, and during that time you could have had the decoupling of the weak nuclear force and electromagnetism. Anyways, I realize this is a whole lot here. The point I'm trying to make here is the book is very, very rich in talking about what we now know of is the standard model of physics and where the uncertainties still are. For that reason, since the beginning of the Breaking Math podcast, I've wanted to do a book discussion on this book. I'm also thrilled to announce that I asked the author, Jim Baggett, if we could do a book group discussion on the podcast, and his answer was an emphatic, sure, go for it. So here we are. Now, I'm not going to dive more into that today, but I've tried to get you to read the book, and I've sent you a little bit of it. What do you think about it so far, Autumn?
At Zaxby's, we don't just make chicken fingers. We make the most premium tenderloin, 12-hour marinated, hand-breaded, fried to golden perfection. Deserves not one, not two, not even three, but your choice of 12 dipping sauces chicken fingers. Chicken fingers that you can dip, dunk, or drizzle in ranch, and Zax sauce, and spicy Zax sauce, and honey mustard, and tongue torch, and barbecue, and I'm out of time. Woo, saucy! Zaxby's.
I'm absolutely thrilled because, it talks about some of the science riffs behind the scenes.
Yeah.
Every good science story does always have some sort of conflict. People and collaborators toss out ideas, and you get some really interesting results. Do they all agree at the beginning? No, never. When do people actually agree in science? When they have these different theories. But the best science comes from trial and error, like scientific method.
Yeah, actually, now that you mention it, this book covers a huge rift that was an amazing thing to read. The letters between Albert Einstein and Niels Bohr arguing about the proper interpretation of arguing about the Copenhagen interpretation of quantum mechanics. And I've never read something that was more thrilling to read. It was like watching two titans battling, to the death, but it was just intellectual ideas, And
Right.
I think that Albert Einstein would write a whole thought experiment, about how it's not that quantum mechanics, or it's not that nature it has fundamental uncertainty. It's that it is certain. It's just that we are limited in our ability to measure it right now. And he said, I'd like to think that the moon is there even when I'm not looking at it. That alludes to the measurement problem in quantum.
Absolutely. I think that also brings in a lot of other interdisciplinary questions that we have, right?
Oh,
So
yes.
let's look at also the big picture of things. We talk about machine learning, AI. We're taking apart all of these other areas that integrate what is the design of a coffee cup even, and why do we have a handle on the side and not on the bottom?
Yeah.
Right?
Yeah. Yes.
So if you're thinking about that as a scientist,
Mhm.
that makes that very, very interesting with your basic fundamentals of design.
Yes.
But also we have big questions such as election systems.
Mhm.
We just did this major interview about election systems and what sort of voting that we have going on. What should work better? Why is our system antiquated?
Yeah.
We have a lot of other conversations that we want to reach out to political scientists and social scientists.
So generally here, as we pivot topics here, I appreciate how you bring up all these other grander questions that relate. In other words, it seems that we could describe our ambitions with this show as being an interdisciplinary discussion using mathematics as the bridge of conversations. And this comes up as a theme in the episode you're talking about. We interviewed Ismar Volic, who was from Bosnia. And he talked about the necessity of using mathematics to ensure stable systems of election. Great interview. But throughout the interview, he kept talking about a strong desire to talk with social scientists and with anthropologists and with people who can talk about human behavior, modeling human behavior, psychology, also systems of power. It's a rich area. It's a very, very, very rich interdisciplinary area for people in different fields to overlap and work together. And that's kind of cool. That's kind of cool, isn't it?
Absolutely.
Yeah.
Also, things that we really have wanted to explore are the ability to model neuroscience, right?
Yeah.
And machine learning with that.
Yes.
So
Yeah.
there's a lot of questions with neural networks, right?
Mhm.
So think of a disease that can be modeled. When you're modeling something with pandemic, you're having that, what sort of system in which you have a population
Mhm.
and it starts from one person, how does that spread on to the 20th person
Mhm.
of that nature? And how do we really synthesize that and maintain the structural integrity of our system while modeling these patterns? And does that even have information spread
Mhm.
from one person to the next? And that could even be information on politics and voting. How does that model even correlate to something as simple as picking people for ranks for a political campaign?
Wow. Yeah, that's fantastic. Oh my goodness. A book that brings together trivial, we say trivial, like lighthearted things like memes or even jokes or styles, for example, that are spread like on music videos and stuff and relating that to political identities and ideologies. Wow. Oh, fascinating stuff. Fascinating stuff. It's really cool. And when you talk about the spread of things here, yeah, these are areas where different fields overlap. Like with the training of neural network models, there's a reinforcement function, and there is a distributed, both a distributed but also an integrated knowledge throughout neurons in a neural network. And I sometimes wonder if humans themselves could be individual neurons in a bigger neural network per se. I don't want to go, too conspiracy theory here, or rather, I need to find support for that idea, but that idea has crossed my mind before, So what we've been talking about is great big ideas and small ideas. I like to refer to the big ideas in the Breaking Math podcast as like big logs in a fire. You know what I mean? Like when you're building a campfire, you bring together these really big logs, but you also have kindling as well. And the big logs will burn for a long time. And with respect to a podcast about math or science, I think of the big logs as the big ideas that you marinate on. We can talk about them, but they're like multiple episodes, and you just sit there and ponder on them for like a long time. Like I think that's how Einstein was. He was a big log kind of thinker. But then there's also fun topics that are sometimes called popcorn topics or kindling topics, because sometimes you just want to hear some gee whiz cool facts. I'm not going to lie, I get a dopamine rush from really well presented gee whiz facts. Don't we all?
I actually love doing that. Like you go into a lot of the big topics,
Yeah.
And I love stuff that's really fun and interesting and will hold the attention of the audience on something new, whether it's something such as how do origami robots work in one sense, then
cool.
Bringing that over to even fashion design and integrating the mathematics behind digital fashion.
Wow.
You don't think of how these topics really correlate. Or something that I've been really passionate about that I know people talk about in a sense of, crypto, what is the usage? What is the sense behind this stuff? Folks don't realize the very, very practical applications that these topics have, whether it's your engineering licenses or even digital certifications. And finding practicality in sometimes these little niche topics that people talk about, or finding some interesting topic in left field, or even talking to people at Amazon about their systems and supply chains, or what's the new up and coming research. I love those topics just as much as us doing our big reviews and our book reviews.
Yes. Yeah, that's been fun. Haven't you felt like it's pretty awesome having a math podcast that's been going on for this long? Because what I feel fortunate, we get emails every single month, multiple emails from book publishers about here's the latest, math, the book that describes mathematics this way or that way. It's really cool. So like like you get to talk to a subject matter expert who took the time to write a book. So it's I don't know. I think it's been, yeah.
And I think the thing that we want listeners to know about this is that we're inviting you to come work with us.
Yes.
We
Absolutely.
want this to be sustainable. If you're doing a cool topic or you think it's cool, we may not even know about it.
Yeah.
If it has anything to do with science, art, and the integration of that with math, maybe engineering, maybe machine learning, right?
Yeah. How about a Broadway musical about mathematics? Any takers?
I think that would be just as interesting.
Yeah. No, I think it'd be awesome. Yeah. It'd be a way to experience the math. Multi-sensory, multimodal experiencing of the math. That's actually what we didn't think of a whole lot. Actually, is other ways to not just know the math, but to experience it.
Absolutely.
If you've been to like one of those science museums for kids, we've got one here in Albuquerque called Explora, where there's this there's a bunch of sand on like a metal plate, and it'll vibrate at certain frequencies, and you can see the sand suddenly form into a pattern that looks like a violin or something like that.
Those are the best.
Yeah.
And being able to just experience the math, knowing what we're doing, whether it's hands-on applications or some really interesting workshop, those are the things that make math and science fun.
Yes. No, I agree. So please, on our website, just go to our website right now, breakingmath.io. I'm not meaning to sound like a salesperson here, but no, seriously. There's a section. There's a section on how you can collaborate with us, and we'd love to see your emails and celebrate math and creativity and science and the human experience together. That would be awesome. Now, super quick, you had mentioned earlier about machine learning. And about some of the deeper questions. There's another book that I wanted to mention, similar to A Quantum Story. You think it's a good time to bring that book up real quick?
Go for it.
Okay, very good. So one of the deepest questions that I've heard anyone talk about, whether it's science or philosophy or anything at all, is the mystery of human consciousness. Now, I'll mention a book for you guys, and the book is rooted in thermodynamics as well as ideas about zero. The book is called Incomplete Nature. Again, it's called Incomplete Nature, and it's by Terence Deacon. Now, some of the ideas are a little scary. And by scary, I mean they make me feel a little uncomfortable, but they're important ideas. And they are ideas about where does consciousness come from? Now, there's a running joke on Twitter that I've discovered that nobody has actually read the entire book. Nobody has read it, but everybody's read the Wikipedia page. But essentially, one of the themes that the author talks about is the role of the number zero. And the way he describes it is, not only him, but others as well, is zero is very, very important in mathematics. It's not only, a placeholder, but it's not just emptiness, but its role in describing is things are not defined only by what is there, but equally by what is not there. Like both positive and negative spaces, or rather space and the taking up of space together are important in describing the reality of something. And he goes on to describe various phenomena in the human brain and the human body. And his implication is that the arisal of the conscious feeling of you is similar. It is defined both by what is not there as well as what is there. I didn't mention the author, Terence Deacon, has written 2 books. One of them is called The Symbolic Species, which is all about the origin of language in humans. And the other book, of course, is the one I'm talking about now, called Incomplete Nature. Deacon's first book, The Symbolic Species, focused on the evolution of human language. In that book, Deacon notes that much of the mystery surrounding language origins comes from a profound confusion about the nature of semiotic processes themselves. Accordingly, the focus of Incomplete Nature shifts from human origins to the origin of life and semiosis. Incomplete Nature can be viewed as a sizable contribution to the growing body of work, positing that the problem of consciousness and the problem of the origin of life are inexorably linked. Deacon tackles these 2 linked problems by going back to the basics. The book expounds upon the classical conceptions of work and information in order to give an account of intentionality that is consistent with eliminative materialism and yet does not seek to explain away or pass off as epiphenomenal the non-physical properties of life. So he talks about like consciousness can be hard to study because you can't, take away everything that's not conscious. And are you left with consciousness? No, you can't, because consciousness is what's there and what's not there. Anyways, it's really, really cool. Now, the book goes on and on. He basically, he attempts to address, traditional ideas from Rene Descartes in the mind-body problem, which is a dualistic look at things. And he takes ideas from Aristotle and he tries to rephrase them using modern understandings of thermodynamics. So, this book is a doozy. I think I was talking to you about this book as being very similar to dropping like a watermelon into a pool. Like, you know what I mean? And again, it's similar to the book Gödel Escher Bach. Now, of course, Gödel Escher Bach is written by Douglas Hofstadter. He's another person who attempts to describe where consciousness could come from material processes by something like a brain that maps reality, attempts to map itself. But then there's the incompleteness problem because you can't fully map yourself unless you map yourself mapping yourself, or a brain thinking about a brain. Thinking about a brain. And so
it's mapping itself.
Yeah, it's mapping itself. So that's the ideas here. And again, I think that these are worthy ideas here, even just for the sake of like, if you're going to do some task like, learn karate and you learn a black belt, I think taking on this book and the quantum story book together, that's like the black belt of science and philosophy conversations, don't you think? Even if the books are wrong or even if they're critiqued, I think they are more than worthy to have conversations about on this podcast. So we should have people who have delved deep into those books and try to take on that boss fight, if this were an RPG, and report to us on this podcast, and break down some of those $20 words. Yeah, they hit so hard.
Math, right?
Yeah. No,
boss
exactly.
fight time.
Exactly. Yeah. But, the reason why we bring up that book, no, for reals though, is because we're talking about things like neural networks and artificial intelligence. What would a neural network need in order to actually be conscious? We don't think it is. We think right now, I was having a conversation with a physicist at work who believes that a neural network right now is about as conscious as something like a snow avalanche, literally.
Yeah.
Think of, and really it's just a statistical response to an input, and it puts out what it believes is the best statistical output. So it's an avalanche. It's sort of like an avalanche in some ways, but also kind of like playing an arcade game, pinball machine. Exactly. Yeah.
Why am I thinking of Street Fighter at the same time?
Oh my gosh. I was telling you this, speaking of Street Fighter and being creative, do you all remember the game Street Fighter? It's kind of like, more of a PG-13 version of Mortal Kombat, where you have these characters that fight like in Smash Brothers, but then you have the bonus levels where you're like smashing a car in a certain amount of time. Can we do that with math? Like imagine playing a little character on screen and you're solving a math equation, but it's got the same Street Fighter energy and the same music. You know what I mean?
Absolutely.
I think that'd be awesome.
I think we should have that as an overlay.
Yeah.
For MATLAB and Wolfram Alpha, as it does all the complex stuff. Do.
Yeah, you're smashing this like car to pieces, but it's the math. Or like, do you remember the game Dance Dance Revolution?
Yes, I love
this game?
DDR.
Yeah, you were stomping on these things here, and this dude was dancing. There needs to be can someone do a math equation version of that? You're there solving a problem, and suddenly somebody like turns into a ninja and just slices up. I don't know. I know they have like Fruit Ninja, but like you can destroy like a mountain or something. You know what I mean? Like pick something to destroy, and as you're solving it, when you solve it correctly, it's the same satisfaction as playing Tetris, and you watch the Tetris pieces go. It's like primally. I don't want to call it an addiction here, but it's a source of dopamine. So imagine solving some really hard partial differential equation, and like your reward for that should be something cool, like seeing a giant robot, whatever, just blow up bit by bit. That'd be pretty cool.
Absolutely.
I'd play that game. I would play that. That would be the gamification of complex analysis.
Right? Yeah.
So you guys get it. Yeah. This is our creative conversations. We talk about the ethics of gamifying activities and also deep conversations about the nature of reality, the limitations of human knowledge, and where does consciousness even come from? How's that for you? Are the other rival math podcasts doing that? Are they? No, I'm just kidding. I have no idea. They might be. I have not listened to them much. So
I don't think so. I don't think so. Not yet. So that is more to come for all the people who want to do this or want to volunteer to have it with our show.
Oh, and super quick. So I want to talk about, we said in the beginning, we talked about the name of this episode is called The Math Lounge. So the Math Lounge may exist only in our heads right now as this cool nightclub that's themed, with mathematics, where I was talking to when I taught 6th grade math, we're like, yeah, that'd be like a neon sign or a neon cosine. Get it? I don't even know. Like, all the art would be mathematics themed and like there'd be fractals and stuff. I don't know what would be into said Math Lounge, but like you have to imagine one. We actually made a mathematics playlist that we're calling Math Lounge. I have it available right now on YouTube Music. So you can listen to the creators of the Breaking Math podcast and hear what kind of music we like. You want to mention any songs that you're going to put on your Math Lounge Breaking Math playlist?
I think I want the listeners to actually check it out for once.
Okay. I'm going to spoil a few songs real quick. I've been listening to a YouTuber who does a lot of heavy metal songs in new styles. I believe his name is Anthony Vincent, and he does things like Genie in a Bottle by Christina Aguilera, done in the style of Tool. He also does things like Man in a Box by Alice in Chains, done in the style of new wave 80s synth music. It's amazing. So I put a lot of Anthony Vincent in there. Also other covers of Tool done by piano and done by guitar. I've gotten really into heavy metal lately, and piano and orchestral covers of it. So yeah, that's just kind of been my thing. So yeah, go to YouTube Music and search up the Math Lounge playlist. It's ours, and let us know what you guys think. We'd love to hear that. We'd love to share our playlist with you and listen to it while you do your own math equations. Thank you so much for joining us on this episode. By the way, I had the creator of this episode create a Math Lounge Breaking Math theme, and it was kind of it's described as like, imagine like a red carpet grand opening of a brand new nightclub and all the celebrities are there. So let's take a listen as we end this episode to the Breaking Math theme.
Yes, and actually before we go, a couple reminders. So for folks that are listening in today, you want to know where you can find us, we have a new website, which is breakingmath.io. We also have a merch store attached to it. So if you like Breaking Math and you want to get a t-shirt, you want to support us, we're going to have some really cool shirts and posters and mugs in there as well. We'll also be slowly updating a YouTube channel and having a lot of our episodes hosted on YouTube. We're expanding to all of our social media. And finally, last but not least, we do have a website where we encourage you to go check it out and also contribute to our blog.
Yeah, we love that.
We're looking to have everybody on there.
We have merch too. So we want to design some awesome merch that has math equations written in like the coolest script or maybe graffiti or something like that. All those ideas are coming. They're coming soon. But check out our merch and give us ideas for merch too. If you want to have like, I don't know, like the Taylor expansion series, like done, as I said earlier, in graffiti writing or some other cool font or some design. I think that would be awesome if the math enthusiasts start to represent with their clothing. That'd be pretty cool.
Definitely. So,
okay, without further ado, let's play the club music presented to you by Elliott Smith, the composer of the Breaking Math theme. Here is the Math Lounge remix for your enjoyment.
We officially invite you to experience the math, dance with the math, break the math.
Now celebrating
101 years.
Episodes.
Whoopsie daisy.
Calling all intellectually curious, microcosmically minded, explorers of the universe, people who used to do all the work for groups at school, admirers for those who used to do all the work in the groups at school, university professors looking to nitpick, pod people,
nerds, geeks, and number-loving freaks.
Absolutely. All are welcome to a podcast called
Breaking Math.
When When it comes to Zaxby's Fingers, there's a few non-negotiables. It's gotta be only premium tenderloin, marinated for 12 hours and fried to crispy perfection. What is negotiable? The flavors you create mixing our 12 signature sauces. Woo, saucy! Zaxby's. At Zaxby's, we don't just make chicken fingers. We make the most premium tenderloin, 12-hour marinated, hand-breaded, fried to golden perfection. Deserves not one, not two, not even three, but your choice of 12 dipping sauces chicken fingers. Chicken fingers that you can dip, dunk, or drizzle in ranch, and Zax sauce, and spicy Zax sauce, and honey mustard, and tongue torch, and barbecue, and I'm out of time. Woo, saucy! Zaxby's. When it comes to Zaxby's Fingers, there's a few non-negotiables. It's gotta be only premium tenderloin, marinated for 12 hours and fried to crispy perfection. What is negotiable? The flavors you create mixing our 12 signature sauces. Woo, saucy! Zaxby's.